Here we will see multithreading overview in C#. First we will see what is multithreading. Multithreading is a method to implement concurrent programming where multiple threads operate simultaneously. As you know, threads are lightweight processes that signify the execution path in a program. Here each thread performs different activities. For example, if we have a class and this class contains two different methods, then using multithreading, each method is executed by a separate thread. Since multithreading works simultaneously, that is, multiple tasks execute at the same time, it increases the efficiency of an application and reduces the CPU cycle time wastage. The main advantage of using multithreading is maximum utilization of CPU resources. Because multithreading works on time sharing concept, that is, each thread takes its own time for execution and does not affect the execution of another thread. This interval is given by the operating system. Multithreading in C# defines executing multiple tasks at a time and uses system.threading namespace to create multithreaded application. A basic example of multithreading is downloading two files from two different tabs in a web browser. Each tab uses a new thread to download the requested file. No tab waits for the other one to finish. They are downloading concurrently. The following picture shows a simple explanation of concurrent execution of multithreaded application. There are some advantages of multithreading. Thread can be utilized for free up the main thread. Threads can be used to break up the task into smaller units that can be executed concurrently. Threads are used to maintain a responsive user interface. Threads are used to make an efficient use of processor time while waiting input-output operation to complete. Threads are used to split large CPU-bound tasks to be processed simultaneously on a machine which has multiple processors. Different processors execute different threads simultaneously, so performance improves. Next is disadvantages of multithreading. First is slower execution. On a single core machine, the task which is performed by the single thread is performed much quicker than if the task is performed by the multiple threads due to context switching. Next is maintainability. It is difficult to maintain the code written for performing tasks using multiple threads. We need to do exception handling inside the worker method, as any unhandled exception can result in the program crashing. Due to context switching, it is very difficult to write, understand, debug and maintain the code running with multiple threads. And if the machine is a single processor, then the multithreading causes the overhead over the processor as it is using context switching.